Hi, good afternoon. I'm Deborah Balk. I'm a professor in the Mark School of Public and International Affairs at Baruch College at the City University of New York and at the CUNY Graduate Center. And I'm also the director of the CUNY Institute for Demographic Research. Today, I am joined by my co-author and graduate student in the sociology department, Daniela Tagtachian, who is co-author of one of the three studies that I'll be presenting as part of this presentation today. So without further ado, we'll be talking about the rising tide, population exposure, and change in the low-lying coastal areas across the globe and in the United States. We thank the Stone Center for inviting us to present in their series on Inequality by the Numbers workshop. To get started, I'll give you the little prologue here is what was the motivation for this study. This is work that has unfolded over more than a decade, and it was to address questions that were pressing then and that remain pressing now. Part of the work was motivated in part to enter the policy discourse, in fact, as a first stop on the Intergovernmental Panel on Climate Change. As the work that Daniela and I will later talk about that gets to more local work and ideally has its way into other more local work, for example, that gets done by the New York City Panel on Climate Change. So there are many places in which the policy discourse interfaces with this. But that was a partial motivating factor. And finally, the work is motivated by an interest to retool and blend methods and approaches within the population studies discipline at large, where we use spatial methods in support of descriptive population trends rather than the methods that are traditional to demography. So let's start with the big picture. We have uncertainties we have some certainties in an uncertain time. In particular, we do know that there will be climate change in this century. It will become hotter in most places of the world. We'll see much more variability in our weather. Sea levels will rise as depicted here by for New York City across the century being forecasted out to 2100. We will see more flood-prone areas in general, both in coastal areas and inland areas. Many places will be stormier, and some places will also be drier, maybe some of the same places that will also be more flood prone. At the same time that we're seeing these climate changes unfold, we can expect to see demographic changes as well. We will definitely see more people living in cities or urbanization unfolding, as well as population aging, which is what is depicted here in this, the fastest growing age group. And this is the population of individuals over age 65, which is represented here in this pink line. This is a forecast from or projection from the United Nations Population Division. And this goes also out to 2100. So this is the backdrop for the work that will be described today. The evolution of, this fits into an evolution of work within the IPCC, the Intergovernmental Panel on Climate Change. They produce assessments periodically, and they had very little attention early on to urban. In fact, in the third assessment report in 20 plus years ago, only the role of population was noted as important for understanding future climates. But between that, the 5 years or so that elapsed between those two, there was an effort on the part of my colleague Gordon McGranahan and myself and others to produce a study that would look at the population distribution of people living near seacoast. And I'll summarize that, but that work was done, the initial work on low elevation coastal zones was done in large part because of what we found, which is that those zones are disproportionately urban. And that plays a role in the first mention of human settlements in the context of population exposures and adaptation frameworks in the fourth assessment in 15 years ago. So small island states are also quite prominent in that report, and you'll see some of that also showing up in our work. Similar then, 5 years later, we see urban areas. We also see a development of the shared socioeconomic pathways, which are a way for thinking about demographic futures along with carbon emissions and futures associated with the climate. We saw a special report about less than 5 years ago on global warming, what global warming of 1.5 degrees Celsius means for cities. And then most recently in the sixth assessment, we've seen 2 chapters, both in the impacts assessment and adaptation and vulnerability working group and in the mitigation of climate change working group on cities and settlements and key infrastructures, and that with urban systems and other settlements. So this work aims to feed into providing, the way those assessments work is they look at the body of literature out there. They themselves are not conducting fresh research much of the time, but combining the research that others do. And that collection, so we're trying to contribute to that collection of work. And finally, forthcoming in the 7th assessment will be a special report on climate change in cities. So a few key messages from that, the 6th assessment are that in all cities and urban areas, the risks faced by people and assets from hazards associated with climate change, they've increased already. The number of people expected to live in urban areas highly exposed to climate change impacts has substantially increased. Evidence from urban and rural settlements is unequivocal. With impacts being felt disproportionately by urban communities and with the most economically and socially marginalized being most affected. But that adaptation gap still exists in all regions of the world and for all hazard types, although exposure to the limits of adaptation is unevenly distributed. And with some emphasis on understanding the role of particular cities and financing cities and so forth for their work on climate adaptation. And then finally, putting between the city-specific and global urbanization trends that now is global urbanization itself offers a time-limited opportunity to work toward widespread and transformational adaptation and climate resilient development. These are from that report itself. This is the framework. Again, this is based on a mass of evidence from many different studies, and we aim to contribute to a continued understanding of some of these trends. So in 2007, we first introduced the low elevation coastal zone. We estimated for the first time that 1 in 10 persons lives in the low elevation coastal zone, which is measured as 10 meters contiguous to seacoast. I'll describe that in a moment. Most countries had their largest land area in it, and with any land area in it had their largest city in it. And small island states and deltaic countries and their cities were at much higher risk. And then furthermore, we learned that 1 in 8 urban persons lives in the LECZ, with city dwellers in Africa and Asia at disproportionate risk. So, and this is important because most of the future population growth of the world will take place in the cities and towns of Asia, Africa, and Latin America. So this is based on a very simple method, but it depends largely on the quality of the data, both demographic and satellite data. Here we see small aerial census units for, these are the administrative boundaries for which population counts are available in Vietnam. This is how we measured the urban extent from a database called GRUMP, the Global Rural Urban Mapping Project, which was based largely on nighttime lights. And then finally, we used the Shuttle Radar Topography Mission, which was a satellite-derived data set to estimate the low elevation coastal zone. And so they are, the low elevation coastal zone is 10 meters contiguous to seacoast. Important to know. And at the time we did this work, it was not possible to differentiate between given the error in measurement in that data set, to do finer cuts of that. So the conclusions we had from that study were that the LECZ covers 2% of the world's land area, but contains 10% of the world's population and 13% of the world's urban population. A disproportionate number of countries with large share of their populations in the zone are small islands, but countries with a large number of populations in the zone are not unexpectedly large countries, and particularly large countries with heavily populated delta regions. On average, low-income countries had a higher share of their population in the zone, 14%, than wealthier countries, 10%, and even greater disparities in urban shares, 21% versus 11%. I reported that, so I won't say it again. Some countries, notably China, urbanization is driving a movement up in population toward the coast, so very explicit policy to move people into these more hazardous zones. that we concluded that reducing the risk of disasters related to climate change and coastal sediments would require a combination of both mitigation, migration, and settlement modification. So all hands on deck. So, the study that I'm going to cover today is an update to those global estimates, as well as a decomposition of that further into deltaic and non-deltaic zones, and then finally some focus on the U.S. coastal states. So this is moving to that first study, the new global estimates. Here we see that we see the darker the shade, in fact, the black shades indicate that at least 10% of the population lives within the low elevation coastal zone. This study came out last year, so you are free to go find it and read it or use the data. So why did we bother updating it? There have been substantial improvements in underlying data and methods. There were improvements in the horizontal and vertical dimensions of the digital elevation models that were used for the basis of constructing the LECZ. It also now allows for distinguishing two zones, 0 to 5 and 5 to 10 contiguous to seacoast, which is important because people who are at 0 to 5 are at more imminent risk, without a doubt, than people who are in the slightly farther field in the 5 to 10 meter zone. The population data and the models used to create population grids or distributions, spatial distributions, they've improved in the resolution of the underlying census data. Many new models of population distribution, so they're different. You can pick and choose what model you like, and some have time series. And this allows for a range of spatial population estimates and to look at change over time. And also the urban proxy data and models, I used the term GRUMP. That was an early database that we used based on nighttime lights, but there have been improvements to the lights. There have also been big improvements to the times by the remote sensing community in the Landsat archive, and creating additional higher resolution satellite imagery to construct settlement models. And there's a whole class of models that are by the Global Human Settlement Layer project of the JRC, and they produce a data set that we will use prominently here, but we also look at data using new time series from night lights data as well. So these different models, these proxy models for urbanization, they're not modeling urban, they're measuring something associated with urban, whether it's the built structures or lights. They do allow for distinguishing urban areas along a continuum rather than just looking at urban and rural strata dichotomies, which is historically the way we've gone about this. And so those allow for the characterization of built up and population density of locations, as well as the comparison of different schema by these different data sets. And I also want to point out the fact that there are these multiple time slices now of these data sets, different observations. Those temporal data can inform projections, future projections, which are an important component to the motivation of this work and work that can continue from it. The sensitivity analysis, the takeaway is that data choices really matter. Large differences in the estimates of potential sea level rise, data sets and coastal hazards, but there's high agreement for urban centers and rural areas, but less so for the harder to classify areas in between. There's some consistency though in our estimation, despite these important differences. Every source we evaluated shows that the LECZs are disproportionately urban, and that urban population in the LECZ is growing at a faster rate than we see outside of it. Fitness for use matters, so it really depends on the respective use cases, whether you need data a longer time series, whether you might have better local data, and these are reviewed in some detail in our paper. So switching from global to regional, so Asia, prominent region, as I mentioned, and I just, in this study, it differs from the global study in that we spatially delineate major deltas. It's a comparison of the LECZ in and out of deltaic areas, and this necessitates a focus on Asia and its subregions, which I'll review briefly. It differs from prior studies of population in deltas because it also looks at change over time and by built up characteristics, not just population change. And it looks at exposures in the LECZ, what we delineate as the LECZ, as opposed to just the entire deltaic region. And it looks at the the entire region, which we call 0 to 10. So as opposed to what I was showing previously, which divided them mutually exclusive groups, here we're looking at 0 to 10 as the entire region, and then we look at the subset of that region that's in the 0 to 5 meters only. So here we see the concentration of the LECZs and deltas. We see we're looking at population densities globally and built up densities, which are the same settlement model that I discussed earlier. It allows us to estimate the amount of land area that's built up. And so the land in the deltaic, this farthest right bar in the LECZ 10 was 2.6 times as densely populated as non-deltaic LECZ land, this orange bar, in 2015. And non-deltaic land was 4.6 times as densely populated as the land outside the LECZ whatsoever. So much greater population densities. And we see a similar pattern also associated with the built-up densities. And importantly, these deltaic densities are regionally and locally heterogeneous, which we'll get to shortly. So if we look at them in Asia, it really stands out with far higher population densities. Its population density outside the LECZ is 4.5 times as high as the rest of the world. It's non-deltaic, that's the comparison of this light yellow to this light yellow, but it's non-deltaic and it's non-deltaic LECZ. The orange bars are roughly the same proportions, but the deltaic zone in the 0 to 10 LECZ in Asia is much greater. It's close to 6 times as high as out the rest of the world. In absolute terms, Asia's LECZ 10 deltaic areas have an average of almost 1,100 persons per square kilometer compared to 184, less than 200 persons per square kilometer in the deltaic LECZ outside of the region. So much important differences. So turning from densities to growth, and the growth rate is highest in the deltaic LECZ. It's true everywhere, but especially in the built up of the 0 to 5, which is this dotted line, which is greater than the average in Asia. So, and then we see that in regions of Asia, the growth rate in the deltaic regions of East and Southeast Asia, meaning these orange bars, we are highest and much higher than we see in the non-deltaic LECZ, so in the rest of the LECZ. So the deltaic areas are really quite a bit higher. And this may be just the makeup of these particular regions, particularly in Southeast Asia, which is very, riverine and deltaic by nature, as opposed to like in South Central Asia, that includes say India, which has lots of its population living well beyond the deltaic areas that it's also home to. So although South Central Asia also includes Bangladesh, which has a very large delta. So, but this is partly important in the context of having extremely high population densities to start. So these growth rates are occurring on very, very high concentration populations. This was a very quick overview of this particular study. It's under review now, so hopefully it'll be available soon for public consumption. But just the key takeaways here, that in unpacking the LECZs and their they contain large concentrations of population in built-up areas, especially in these deltas, and the LECZ 10 accounts for about 2% of the land, but is home to 11% of the world's population, and 11% of the built-up area. The LECZ 10, the deltaic LECZ 10 accounts for only 0.35% of the world's land, very small fraction of the world's land, but more than 3.4 or almost 4% of the world's population, and 3% of its built-up area. So those are sizable. Those ratios are significant. And of course, as Asia is at greatest risk, and even within Asia, it's not homogeneous. We see lots of variation within Asia. And finally, there's this urbanization that's occurring in deltas. There's considerable variation within Asia, but the exceptionally high population and built up densities in East Asia, deltaic LECZ 10 and 5 suggest that both environmental pressures and risks are likely to be especially intense in this region, and its growing urban areas. This might create a process that some people recognize as lock-in because we build cities for tomorrow. Like today, if you look around us, the city that we have today was built many years ago, and this may be underway. And this creates it's especially precarious because this type of urbanization may lead to sinking cities, confounding sea level rise processes underway from climate change to sea level may be accelerated in these regions, confounding the risks. Okay, from this we're going to go, so clearly we see that there's not a uniform LECZ, there's variation around the globe, and we're going to move on to the US. And I'm going to start us off and then switch over to Daniela, who will take it away to close us out from this. So in the United States, this study differs from the global study in that we use 4 decades of census data with a richer set of variables. It's got population and land exposures, and urban rural as defined by the US Census, which the other data set use these global proxies. And we use also age distributions, race and ethnicity, and housing tenure in this study. And it differs from prior studies in the US that have been done by NOAA and other colleagues in the population research community, in that we use the finest spatial unit available, and that is census blocks. And we define a coastal county here as any county that has any land area that's in the LECZ. Other studies might use a slightly different criteria, that it's within a certain distance of the coast, for example. Or that it's contiguous to coast, which is, but for us, it just has to overlap with our low elevation coastal zones. And our low elevation coastal zones that we use are the same Merit DEM model that I just presented results from as the primary results from the previous global study. So, and we still summarize our data by counties and states, but it's formulated from small census blocks rather than tracts or counties themselves with any land area, and then we sum them up. Nobody would want to do the analysis at the tract level. The block level. The blocks are, administrative units. They have no beyond that. They have not so much meaning. So initially, we find of the roughly 3,000 counties in the lower 48 states, about 13% of them have any land area in the LECZ with more than 34 million persons at risk, roughly 1 in 6 persons. And that population exposure is even more concentrated, with only 55% of the population found in these top 25 counties. And the colored dots here tell you whether they had the same rank as they did 40 years ago. So and Miami-Dade had the highest exposure in 1990 and still has the highest exposure, followed by its neighbor Broward County. So, but we can see if you can see that there's there's a concentration both with a consistency across county and a concentration within states. So. So of just these 25 top counties, that's roughly 16 million. And of the total, again, it's 34 million. And this, by the way, also distinguishes between the 0 to 5 and then, and it's a slightly more complicated measure, but in this case, you might compare the 2 darker ones to the lighter hues to get a sense of this something similar to the higher risk areas versus the lower risk areas in the global study. This is a complicated slide. It shows for all the states that have any land area in the low elevation and any state with a coastal county. This is now restricted to just the states with coastal counties. We look at total population growth rate, and then we pull out a few states for close, states that we're well aware of have some risks, like Louisiana, Florida, and New York. And we look at urban and rural over and estimate population change over the region. And for brevity, I just want the takeaway message here is that change over time varies quite a bit by state. And then we could say the same, change over time varies quite a bit by county. Similarly, we can say change over time varies by race. Again, this is total population, same as the same graph in the same position, but here we see population, white population, Hispanic population, Black population. So these are not mutually exclusive groups because of the way the census tabulates the Hispanic population as well, so to be known. So again, we'll delve a little in greater detail at some of the implications of that shortly, but those are just those variations exist and they're important. But in addition, there are other vulnerabilities that we might care about: age and urban rural status, race and ethnicity, as just mentioned, housing tenure, and there are a suite of other vulnerabilities. And importantly, these vulnerabilities interact, as you might imagine. So I'm going to start with age. Let's just take a look at this. This is all coastal states. We see that in 1990, 1 out of every person across all residents of coastal states was over age 65. But from 1990 to 2010, and this is a variable that is not available at the block level. The only block level variable, FYI, is whether of the population over age 18 that's it. So we couldn't use that to look at population over age 65. So we see an additional 6 million individuals and small increases in the proportion of persons 65 plus to 12.9% in all coastal states. It's not shown on the graph. But the residents of the LECZ are older on average, 14.6% in 1990, rising to 15.2% in 2010. This is true in urban and rural areas. And here's a little graph. And in fact, 15% of urban residents in the LECZ are over age 65 versus 12% outside of it. And in 1990, less than 14% of the rural dwellers in the LECZ were over age 65 as compared to 12% outside of it. But by 2010, these shares had risen substantially to close to 17% within the LECZ and 15% outside of it. So these are notable aging patterns. Switching from age as a vulnerability to race, we see that we know that Blacks have the highest share of population, both in urban and rural LECZs, with about 1 in 5 Black resident living in the LECZ, largely because cities are disproportionately urban and Blacks are disproportionately likely to live in cities. So that's why that number, that's our understanding of why this number is even greater than the averages that we see. And from this table, we see that non-white single race populations are overrepresented in urban areas, both within and outside the LECZ. So here we see the total coastal population along this line. These 4 make up 100%. This 4 makes up another 100% in 1990 and 2020. And we see that any area that is any highlighted, yellow highlighted cell refers to a place that this is just a percentage difference from the average. And we see the urban areas both in the LECZ and outside the LECZ, but more so inside the LECZ, both in the present, in the farther away period and in the present period are Black and are Hispanic, though their percentages are declining, and so forth. And we see that whites are disproportionately represented in the populations of rural areas. So from this, we're going to switch from race to housing tenure, and we'll see they interact as well. And I'm going to pass the mic to Daniela.
Thank you, Deborah. Can you go to the next slide, please? Thank you. So as we've been talking about, subpopulations such as by race and ethnicity should be understood in the context of interactions with other factors that they build on. So they build upon each other and basically create unique conditions that should be addressed and mitigated, especially when coupled with climate hazards. So in the next 3 slides, we'll see housing units within and outside the LECZ by race and Hispanic origin, housing tenure, and urban-rural classification for 2010. Unfortunately, this data was not available in the 2020 census information that was released. In terms of housing tenure, what that is, it refers to the legal relationship between households and the housing unit that they occupy. So in this analysis, we're looking at owner-occupied and renter-occupied housing units. As you see here, the solid color represents homeowners and the hatching represents renters. The red represents urban dwellers and the green represents rural dwellers, all of which are then divided into individuals living within and outside the LECZ. And as you can see, in comparison to the total housing units, whites are overrepresented as homeowners in urban and rural places, both within and outside the LECZ. Next slide, please. So while Black residents are overrepresented as renters in urban places, both within and outside the LECZ. So remember, whites were overrepresented as homeowners. We have Blacks overrepresented as renters. And if you go to the next slide, we'll see that Hispanics similarly are also overrepresented as renters in urban places, both within and outside the LECZ. Next slide, please. And here we see the distribution of housing units by race and Hispanic origin of householders by housing tenure within and outside the LECZ by urban and rural classification for coastal states. And when the data is disaggregated, we find that, for example, Black and Hispanic householders were almost twice as likely than whites to live in urban renter-occupied housing units within the LECZ. Next slide, please. Thank you. So in sum, whites are overrepresented as homeowners, with about 70% of white householders owning their home in comparison to a little over 45% of Black and Hispanic householders. And conversely, Black and Hispanic householders are overrepresented as renters, with more than 50% of Black and Hispanic householders renting in comparison to around 30% of whites. Thank you. So why does this matter? Well, for starters, climate change is augmenting and accelerating the affordable housing crisis. And while low-income residents are particularly vulnerable in areas that are prone to flooding or other coastal hazards, we need to understand the needs of populations with specific conditions. So, for example, low-income homeowners and renters are likely to experience flooding, storms, and sea level rise differently from homeowners, particularly middle and lower-income homeowners, since homeowners are likely to be less mobile and renters tend to have less equity. That said, due to their immobility and increasing exposure, homeowners in the LECZ experience diminishing equity. And while renters are often more mobile than homeowners, renters in the LECZ face diminishing affordable housing options, increasing exposure, and devastating climate-induced financial shocks. So renters are, in addition to all of this, renters are often also overlooked in disaster relief efforts, from buyouts to managed retreat actions. Next slide, please. In terms of lessons for policy and planning, these include the fact that social equity assessments must be part of the climate adaptation and mitigation planning and should be conducted based on the guiding principles of environmental and climate justice, which would be distributive, procedural, recognitional, and intergenerational justice. And this is to ensure that plans do not augment or reinforce existing inequalities and facilitate more just outcomes. Climate justice is a movement to acknowledge that climate change will have differing social, public health, economic, and other adverse impacts on underprivileged and vulnerable populations. A social equity lens should be applied to all aspects of climate planning, from data collection and stakeholder engagement to the decision-making processes and policy proposals. Climate-related disasters disproportionately impact vulnerable communities. And in the United States, this includes, among other things, racial and ethnic minorities, low-income residents, renters, elderly residents, non-native English speakers, individuals with disabilities as well. In addition to examining differing exposures to disasters by subpopulations, we must also analyze interactions between different vulnerabilities and how they build on each other. Given the history of discriminatory policies that have resulted in today's inequities, the displacement effect of, for example, climate gentrification and the role of housing, the role that housing plays in financial stability and intergenerational wealth, housing trends by race and ethnicity, and their relationship to the compounding vulnerabilities associated with the LECZ must be equitably mitigated. Additionally, due to the increased number of seniors living in coastal communities and vulnerabilities of older residents, whether due to their decreased ability to adjust to changes in the temperature, increased social isolation, lack of mobility, special circumstances such as the stressors and difficulties of evacuating assisted living facilities, nursing homes, living in older homes that don't meet the current building codes and actually may be even exempted from participating in programs like the National Flood Insurance Program, or also being forced to prioritize healthcare costs, right to housing costs. We should also analyze the housing trends in the LECZ. So as a note on that, while this research is focused on the United States, many of these same policy considerations are also applicable to vulnerable communities around the world. So thank you again for the invitation, and back to you, Deborah.
Thanks, Daniela. And so connecting from the US, I'm going to go back out. And one of the reasons we can even ask these questions in the US and therefore understand how well we're doing if we were to put in place adaptation plans with a social equity lens, we could use our very census data to help us understand how well we're doing on that score. So data are really an important backbone. And we don't want to forget that important contribution of data to producing a more equitable future. There are some additional lessons that are from lessons from research for this, which is that, this approach can be used with any spatially delineated hazards. We focused on sea level rise and the coastal hazards associated with it, but surely there are many additional coastal hazards that we can't look at, particularly storms are much harder. So, but it can be used, and importantly, it can be used with, a lot of the remote sensing data also, and environmental data are becoming increasingly available to use and easier to use. So if you happen to be a student who's watching this, I just want to, the measures of vulnerability and demographic change come from censuses and surveys by and large. So we have to be, if that's your starting point on this, but you're interested in working with these other data, we have to be prepared to work with interdisciplinary methods and perspectives, often in a spatial lens, to help accommodate these greater trends that we would just otherwise normally put in tables. So, we should recognize that some hazards are going to be harder to study, like storm paths. So we might want to think of new ways of capturing this information, again, relying on areas that the social science and behavioral scholars have been strong. So I would also encourage us as a community to enhance our description and move beyond description. So national statistical offices continue to improve and make available increasingly thematically rich spatial data, but even in the United States, as we make more data available, we have additional constraints on some of the use of those data, and with differential privacy mechanisms and we should be attentive to these changes as they unfold for their ability to use them in these settings. So both plus and minus, we should be aware of the data that underlie all the data that even when we get a secondary or tertiary data set, we should be really aware of what it took to make that data set and what assumptions have gone into it. And what trade-offs have been made at the level of the national statistical offices to provide data to us. I would also encourage us to use place-based findings to help improve our understanding of causal processes behind vulnerability and the demographic components of change. So instead of, we can go beyond where we are now, and that is one of the directions that we should go into. And as a final set of conclusions, I would recommend that we strongly embrace the main research finding, which is that all evidence shows that the LECZ is disproportionately urban, both globally and locally. And in the past 25 years, cities have grown faster inside the LECZ than outside of it, particularly on locations of high vulnerability like deltaic areas and in Florida. So local variability is notable, or Dade County in Florida, which we aren't showing you, but which does in fact take place. Globally, this places deltaic, Asian deltaic cities at very high risk, and in the US, this places more communities of color at risk. Research must be informed, such research has to inform planning decisions, as Daniela spoke to, but also future population projections and the development of scenarios that are sometimes used, especially at a regional and local scale, where our forecasting methods don't work as well when we want to go out long term, which are needed for climate planning. And lastly, we still don't know the causes of urban growth in the LECZ. They remain unanswered. Whether this is due to land expansion of existing cities or the emergence of new urban places, this is an open question. What the role of migration and natural increase is still unknown. And the answers to these questions would really assist in climate adaptation and mitigation. So we've come quite a ways in the last 15 years to understand some of these processes, but we have a long way to go. And those interested in doing this research, I would encourage you to take some of these last few slides and pick up from here. Finally, I want to thank our collaborators. In addition to Daniela, we have a core team of researchers. We've had the benefit of working with a terrific group of research assistants and interns, both at CUNY and at Columbia University, and we had funding from several different agencies over the course of time. My email is here. I'd be happy to hear from anybody who's interested in this research. And the work cited are the McGranahan et al. Paper, which the citations shown in an early slide, this policy report, which is linked here, and the McManus et al. Paper is here. Similarly, if you want to experiment with these data or use them for your own study, the data and code are already available here, and Delta summary data will be coming soon. The US data were built on publicly available data, so those you can recreate on your own if you want. So thanks very much, and bye.